Hello guys, this is a 2007 BMW X5 with a 3.0 liter engine, and trouble with this one is that the cooling fan is blowing the full speed, and I have my picoscope hooked up. This lead is hooked up to a control wire on a cooling fan. This is a connector is right there. There's two thick wires. There's red is power and brown is a ground, and that small green and black wire that is a control wire. So this is a pull down design where the cooling fan has a module, and it actually sends the 12 volts to a power control module, and power control module is going to pull that down to ground. I have my current clamped down at the pump itself, and I'll show you guys the codes, but I was just kind of playing with it a little bit, and most of the time when you have this code it's a bad pump anyway. But I was looking some data, and I got a coolant temperature sensor, and here's the electric pump speed, and it seems like it's just not seeing the speed at all. You can see it on my current ramp, it's just really cutting up, and this is the current from the pump, and then we have this long gap that we got no current at all. It's this looks like one of the commutators is completely open. It's like 12 milliseconds we have a gap when we don't have a current at all, and so they kind of correspond with this with a speed that computer doesn't see it. So anyway, when the temperature reaches around 204 Fahrenheit, the fan will kick full speed until it cools down, and it really blows like a jet engine. I mean, and it's definitely because of the water pump. So now the water pump has 4 wires. There's two thick wires, so that's a red and brown. Those are power and ground, and there's other 2 wires. One is the communication wire, and there's another one also is the power. And I'll get you down to a pump and I'll show you all that. Okay, so here's my current clamp. Let me get the light. I'm going to take the clamp off. So here's the back side of the pump, and you can see we have 4 wires. The red wire is power, the brown is ground, and we have these 2 in the middle. One is power, one is the communication. I already checked those, everything's fine there. There's no voltage drop. It's just we have an open in a pump, and it doesn't overheat or anything, but it has the code, and as soon as the temperature reaches over like close to 200 Fahrenheit, it will kick the fans full speed. So right now we don't have a current through our pump, and we have I was looking the wrong way. It said a 90% duty cycle, and down here we see that our temperature is around 170 right now, 169. So once it gets to around 200, it will start blowing the cooling fan. As soon as it actually turns the pump on, it's going to see the fault, and it will turn the fan on. And it does not have any. It's not going to limpo mode or anything. It runs fine. It doesn't overheat. I guess the pump still can pump the fluid through. It's just you know, this fan blows all the time, and this pump will fail at some point for sure. But it's kind of nice to see the current and the speed that we can see on the scan tool that correspond with our current. And it's nice to, once we replace the pump, that we can verify repair. At 180. I'm going to rev it up a little bit. Okay, we're getting close to our threshold. We're at 195 degrees right now. I think around a little bit over 200 degrees it will kick the fan on. There you can see the pump is on. We could see a little bit of speed on it, but now the fan's gonna kick on. We can see that our duty cycle changed now to 38%. I was looking this number down here. Before it's at the 20% right now, and you can see that we have a dead spot on the pump for sure. It's actually good capture here. I'm gonna freeze it. Look at that. Right now I was seeing the speed. Now it's going up again. Doesn't see the... Okay, I'm going to turn it off. So now here is a, let me see here, wiring diagram. We have basically, there's 4 wires on this water pump. There are 2 feeds, ground, and the communication line between the PCM and the water pump. So this is the electric pump. This is the violent wire. It is a control, and the red and orange are the red and orange. They are power feeds, and the brown is ground. So what I wanted it to do is to get to a this fuse 47, to just pull this fuse out and get the current measurements. So my friend Mike Salazar, he's got his YouTube channel as well. He was asked to send me the the wiring diagram and the location of the fuse. And here's the fuse box, which is actually on the driver's side, on the passenger side. And the fuse supposed to be in here. The fuse from 45 to 49 is supposed to be in this little box here. So we're gonna see if we can find this fuse. But something else also. So I was actually working on this car last weekend, and the owner ordered the water pump from O'Reilly's. It was around $300, and when I was like halfway in it and just realized that the pump is not correct. And this is some kind of special BMW that has some kind of I don't know, some special climate control system, whatever. So here's the correct water pump. We ordered this one from eBay, and it's the original pump. So the other pump looked almost identical. The only difference was that this connector was actually behind the pump, kind of right in here. Okay, so, and the price for that pump was around $350. So when we priced this pump from AutoZone, and here's the price, $962 for the water pump. So we end up ordering this one from, we found it on eBay for around $450. Now we got a coolant and everything. So it's just really weird. I mean the water pump, the cost that much money, I just don't understand that. Now the other challenge that I'm facing right now is to get the pump out. I watched some videos on YouTube, and it's pretty straightforward job. It has the thermostat attached to it, so you have to kind of unhook some hoses. But the trouble on this one, you don't have a room to pull the pump out. So I had to take the radiator and the cooling fan out just to get enough room to get physically, here's a pump right in here, and to get the pump out. And here's my fan, and the radiator is over here. So let's go find that fuse, and that was a so right in this box supposed to be fuse from 45 to 49, and we need a 47. Okay. Now to get to the fuse box, you need to take. This doesn't even have glove box at all. It's all blocked. There's nothing here. So I don't know. And you take this cover off, and then there's has like 3 screws. You take the cover off, and then you take this screw off to drop your fuse box. And right in here, unfortunately, I got no fuse. That box is supposed to be here. That has the fuse 47. It's not in this fuse box. There is another set of fuses in the trunk. Okay, so another set of fuses in the trunk. So you get this open. It's pretty easy to get to it, and there's a fuse panel here, and right on the side you can actually get a paper to find your fuses. And this is actually correct. Actually gotta get some more light. So here's the diagram. Now on the fuse box in a glove compartment on passenger side, there it goes from starts at 1 and goes up to 43, and this is actually what I have. And this is area where we're supposed to have that 47, and it's not there. And that's where this is supposed to be, and it's not. I don't know. So now the other set of fuses goes from 91 to 140. 91 to 145. Now here I see 47, 48, and 49, but I have no idea where they are. I cannot find these fuses at all. There's supposed to be another set of fuses somewhere, but I cannot find them. And on the diagram, I believe it says that 47, it is, you know, at this says the junction box on the right side of dash, where it's supposed to be, and I don't have it. It's not there. So luckily this fuse is not blowing, but if it is, you know, I'll be screwed. I can't get this thing fixed, because if this fuse is gone, you know, change the pump. It's not to do much, to do any good at all. So, all right. Well, I got to get back underneath this car, and you know, get this taken care of. Okay. All right. 2 hours later, the pump is out. It was a job. I mean, I'm not done yet, but it was a chore to get this thing out there. So anyway, everything looks okay. Everything looks identical, so I can proceed with the installation process. All right. Okay, I got everything back together. Now I need to prime the system. I got the extra battery here. The way we're gonna do this is by activating the pump through we're gonna go into the car, and we're going to command the pump to turn on, and it takes like 12 minutes for this cycle to be done. Now on my picoscope right now I have my M clamp, and I'm still struggling to locate the fuse, but I did find basically it still goes into that fuse box, but I'll show you guys. Okay, so right in this fuse box, when you look underneath, this orange and yellow wire, that is the wire that's actually feed to the pump. However, I can still not locate the fuse. So there's like it's right there. See right there. So that is the feed to our pump. But when you're looking at the fuses, when you're looking at the fuses, I still cannot find the fuse. Now I checked all of these 40 amp fuses. None of them are actually fuses for my pump. So I know this could be maybe some kind of internal fuse or something, I'm not sure. But that wire is a feed to our pumps. Okay, so this can be done through a scan tool, or we can just do this. I'm going to put the ignition, and now I'm going to press the button, start button, without pressing the brake pedal. So that's going to wake up the system. So now we're going to put our fan to the minimum, turn the heat to maximum, and then press the accelerator pedal for 10 seconds, and this should activate our pump. So let's see if that's gonna happen or not. There you go, I can hear the pump running actually. There you go. I need to close this. Okay. Okay. Okay, that sounds actually a lot better. Okay, so I'm going to leave this on for 12 minutes. I'm looking at my current ramp and I'm not seeing, maybe I was on the wrong wire. Let's see that. Okay, looks like I was on the wrong wire. It's from the wire next to this orange wire, not the orange white, just a plain orange wire. There's a this connector right there. That's what you're gonna have underneath your fuse box, and then get your current clamp around this wire here, and then that is the feed to the to our water pump. So let's see the current now. Okay, well that's the current. It's kind of weird looking. Now it's off. I guess there you go. That's how the computer is energizing the pump. But now it's off again. Okay, now at full speed. There you go. I still have a I'm going to stop this. It's better. I mean, it's not pulling. It's like now around 12 amps, but on the bottom it's like half an amp. But it's now we had one that was completely dropping down to zero. I'm still kind of not really happy the way this looks, but I mean, it's a new pump and it's running okay now. So I'll have to clear all the codes once this is done. I have to clear the codes and see what happens. I mean, it's definitely better, but I'm still a little concerned about that little area that was kind of dropping down. But I'm doing a second purge right now. I don't think it's needed, but I like to do it anyway. And it looks better, but I'm still, let's see now. So we got here a peak at actually 10 amps, and the bottom's at 6 amps. So actually 3 amps, I'm sorry. It's kind of a big swing between, goes from, it's like a 6 amps different. I don't know, but we'll see if I sound kind of harsh here. I'm not happy about it. I mean, this looks okay, but every once in a while I have this noise. I'm not sure, is it coming from the pump, or maybe the current clamp is picking up something. I'm not sure, because this actually this wire, I would say, feeds other components, so there might be something else that's turning on or something. I'm not sure. You know, I'm not the wire that I'm on right now, so from the fuse box. So anyway, I think it'll be fine. We'll see once we clear the codes if the computer is going to be happy or not. But look, waveform looks a lot better. Okay. Okay. Well, this second purge is done, and I'm gonna go ahead and clear all of the codes, and then we'll start. I was gonna clear the codes. back, no codes present. Alright, let's start it up and see what we can do. Actually, we can, let's just see if the code's going to come back or not. The pump looks a lot better. Let's see. So far no codes, that's a good sign. Before, when I start the car, like the first minute, the code would come back right away, so see, now we're looking at the pump RPM, I believe. Okay, there you go, electric pump speed. Okay, well, that's good. I got a speed on my pump. That's good. Alright, now my current actually looks a little bit better now. It doesn't have that big swing anymore. It's almost only like 1 amp, 1.5 amp min max. So I'm happy with that. I'm able to maintain my speed on the pump all the time. It's not dropping down anymore. Pretty soon the fan should kick in. It's around 200 degrees right now. It should turn on any time. You can check for the codes real quick. I have no codes. That's a good sign. So my point all over about this is just the easiest way to confirm that you have a bad pump. It's simply by getting a current ramp on the pump itself. And this 47 fuse, it still remains a mystery. I cannot find it. I believe maybe it's internal into that fuse box. I don't know, but at least it's not blowing, so my pump is running. So, but it's the power is coming from that fuse box. There's no question about that. So where the fuse is, I don't know. But the main thing is that I'm able to maintain the speed on my pump. I'm not dropping to zero anymore. Looks like I missed it. There were the computer, when the temperature went up to 206, you can see that computer did turn the pump on. You can increase the speed on the pump. The temperature went down. I think this is the time that actually the thermostat opened. And so let's see what happens next. I mean, at some point the fan should turn on. I just want to make sure that my fans are, I mean, they were working fine, but I'm not sure what is the, maybe 110 degrees or something, I'm not sure. I just added my control on my cooling fan. I mean, the computer is controlling. I know when I do this cycle, I think it's, I don't remember the last time what it was, but it's 211. It should kick in any time. Okay, I'm still waiting. It's at 226 right now, and we can see actually duty cycle is 93%. It's basically 93% off and 7% on, and I think they're kicking in right now. Yeah, I don't see much difference in the duty cycle. There was a little slight difference. Yes, it was. It did turn the fan on. Actually, you can see the temperature dropped right there. It's dropping down. So okay, we did see there was a slight difference in the duty cycle, and well, I'm happy now. I just want to make sure that the fans are operating now. Before, because of the bad water pump, the fan, as soon as it reaches like 200 degrees, it would keep blowing full speed. It would never stop anymore. So, and you know, we had intermittent. There was no, the computer could not see the speed. I guess it's looking at the current at the pump itself. So I'm happy with this. Again, that fuse 47, I still cannot locate that fuse. Located the fuse. Maybe it's the maybe a circuit breaker instead of fuse. Maybe it's a built-in into that fuse box. But guys, if you want to do a quick current measurement, just get the current clamp on that orange wire, and so you don't have to crawl underneath the car and do all your measurements. So that will work a lot better. So a little bit of hassle with this car, but it turned out to be okay. So and the price on the pump was outrageous, of course, but it is what it is. Now the fan is working. I can see actually it's 89% duty cycle right now, and fan is not blowing the full speed. So we are changing the duty cycle a little bit, and 90%, and you can see the temperature did drop again, so it maintains the temperature just fine. So okay, well, this is 100% fixed now. I'm happy with this. No leaks on the, no leaks anywhere. So okay guys, that's it. Thank you so much for watching, and I'll see you next time. Bye bye.